Section 7 is standard deviation. Standard deviation is a statistic. It's not a measure of central tendency, though. It's a measure of variation. Standard deviation describes the spread of the data. If the data is very, very spread out, then you're going to have a large standard deviation. If the data is all very clustered very close together, they're going to have a very small standard deviation. So standard deviation measures the spread of the data. How spread out is the data? Standard deviation is a measure of how closely the data clusters about the mean. So if this is your mean and all of your data is hanging out right around the mean, then you're going to have a very low standard deviation. But if this is your mean and you have a bunch of data kind of spread out all over the place, then you're going to have a very high standard deviation. Okay? It's how closely the data is clustered around the mean. The smaller the variation, the more data is clustered. Therefore, the lower standard deviation that you'll have. A sample mean is a vocab word that you'll see in this section. Sample mean is the same as the mean. It's just the mean of a sample. So if you take a survey and you get a bunch of results back, that would be your sample. The mean of those results would be your sample mean. The symbol is still X bar, because it's still just the average. Calculating the standard deviation is kind of tricky. There's a major formula for the calculation of standard deviation, but once you learn the pattern that's going on in this formula, it's actually kind of easy to calculate the standard deviation. So, to calculate standard deviation, here are your steps. By the way, the symbol for standard deviation is right here. That's the lowercase sigma. We've used capital sigma, the uppercase sigma, to represent sums. The lowercase sigma is like that. I'll talk about it here in a second. So to draw a lowercase sigma, start at that little corner right there, and then just do a loop around. It's pretty easy to draw. It's kind of like a sideways 6. Okay, so the first thing you're going to do to find the standard deviation is you're going to find the sample mean. You have to find the mean of the data that you're talking about, X bar, and then that's just going to hang out for a second. Then you're going to take each data point that you have and subtract it from X bar. And then you're going to square that result. You're going to do that for each individual data point. Take the data point, subtract X bar, square the result. Then you're going to add up all of those results. Then, whatever that number is that you get, divide it by the total number of data points that you have. So it's almost like taking the average. And then take the square root, and that will give you sigma. So if you look at the formula, that's exactly what's going on here. We find X bar, and then we take our data point and subtract X bar from it. And we square the result. We do that for the next data point, and the next one, and the next one, and the next one, all the way through all of the data points that we have. So if we have 192 data points, well, we're going to have to do that 192 times. You add up all of those results, and then you divide by the total number of data points that you had. So if we had 192 data points, we'd add up 192 things up here, and then we'd divide by 192. And then once you're there, take the square root, and you'll have the standard deviation. What? This is a shorthand way of writing this. This just means the sum of all of your data points being subtracted from the mean, squaring that result each time, okay? But what this means is this, sort of a longer form. So what I want you guys to do is calculate the mean. On your notes, I gave you lots of space. I want you to calculate the mean and the standard deviation for this population of data. We don't know what the data represents. It doesn't matter. We just want to calculate the standard deviation for it using this formula right here. Good luck. All right, so enter all of this stuff into your spreadsheet on the calculator. That's the faster way to do it. You need to come up with a name for your list. So I'm just going to call it data. That's fine. Shh. And then enter everything in. Now, is this an ordered list? Is everything in order here? No. Does it matter? No, it doesn't matter for this. So I'm just going to type them in as I see them, 28, 34, and so on. How many entries do I have? 25. So I should be on line what when I'm done? 25. Okay. So I didn't skip any. Hopefully I entered them all in correctly. What? I'm going to cross, not down. Okay, so as we saw in the last section, we can have the calculator come up with all of our one variable statistics. So that's what we're going to do. To do that again, you press menu and then what? Statistics and then stat calculations. One variable statistics. That doesn't look like a 1 to me, so I'm going to make it a 1. Okay, okay. My list is in column A. I want my results displayed in column B. That's perfect. So now I got to scroll back up to see my stuff. And what do you notice? The symbol sigma is right there. So had I not told you that the sigma right here was the symbol for standard deviation, you would not have known that this was on the calculator. But it is sitting right here. That does stand for standard deviation. And therefore 2.74226 is the standard deviation for this sample of data, which is exactly what you got using the formula. Okay? The formula is the correct way to do it. However, the calculator will calculate it for you. So that's lovely. All right. Remember, standard deviation is a measure of how closely clustered the data is about the mean. What's the mean here? Come back. What's the mean? Where is the mean?
Standing in front of the whiteboard.
No. X bar is the mean, 30.6. So now this question at the bottom in your notes says, if we changed something, if we changed the 30 to a 70, so this 30 right here, we're going to change that to a 70. So before we do that, let's talk about what this does to the data. What is that 70 now in this data? It's an outlier. So have I made the data more clustered about the mean, or have I made it less clustered about the mean? Less clustered. Now if I make the data less clustered about the mean, what's going to happen to the standard deviation? It's going to grow. It's going to become bigger because the data is now less clustered about the mean. Okay? The more clustered you are, the smaller the standard deviation. So as soon as I have an outlier here, the standard deviation, will grow. And the mean is also going to change. The mean right now is what? 30.4. What will happen to the mean when I change this 30 to a 70? It's going to go up because we have this big 70 over here. It's going to pull the mean in this direction. Okay? So let's grab the calculator and change that 30 to a 70. So on your spreadsheet, go back to your list and just find the 30 and change it to a 70. The columns to the right automatically adjust. Notice the median also changed. We still have 25 entries, but there is my mean. It's now 32.2, and my standard deviation, which was 2.7 something, is now 8.1878. It made a huge change in the standard deviation with that outlier. So that's what happens. I don't know why my calculator keeps disappearing. Okay? That's how you work with standard deviation. Standard deviation is a measure of how clustered the data is. As soon as you throw in an outlier, like this one right here, then lots of wild changes happen to the standard deviation because the data is no longer nicely clustered. So if I had this as my data and I wanted to take a really good look at the mean, what should I probably do? Probably take a good look at that outlier and consider getting rid of it. If I get rid of the outlier, then that's going to change my mean and it's going to change my standard deviation. And I'll get a more true picture of what the rest of the data looks like. Okay? This outlier is so huge that it's really changing things for me. So maybe I get rid of it and then take a look at that new mean or that new median. By the way, notice how much the median changed. Let's bring the calculator back up. The median is now what? 31. What was the median before? If we don't remember, then all we got to do is go and change the 70 back to a 30. It was 30. Did the median change a lot? It did change, but did it change a lot? No. So the median actually is not as affected by an outlier as the mean is. Because remember how we calculate the median, right? The median is still the middle value, the middle piece of data. We just lop off all of the stuff on the outside. So the outliers get lopped off. You can make that 70 192, and the median is still going to be 31. Let's try it. Make that 30 into 192. The median is still 31. And it's because of the way that the median is calculated. That ridiculous outlier is just chopped off, and we don't even care what the number was. It could have been 10 million, and the median is still going to be 31 here. Okay? But now look at what happened to the mean and the standard deviation. The mean is now 37, and the standard deviation has gone all the way up to 31 point something. So those outliers really affect the mean, and they really affect the standard deviation.